Yo, we're gonna turn this amide into a carboxylic acid. Okay, there's two ways to do it. We're gonna do it in acidic conditions and we're gonna do it in basic conditions. So I'm gonna show you both ways. It's really easy. So just look at the difference and just see, like, honestly, it's really the same thing. Okay. What's gonna be attacking acidic conditions, remember, no negative. Basic conditions, no positive. Okay. You know that, you should be able to figure it out. Okay, we're gonna go here, acid base. He's gonna have a plus charge. Damn, why is it bugging? Yo, chill, 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 chill. H here, H here. We have a like resonance, so we have a localized. No, no, we have a delocalized charge. So we just push electrons towards a positive charge. So let me use a different color for that. So push electrons towards a positive charge, and now we're gonna have this. We're gonna have a charge on carbon. And so now, who do you think is gonna attack? Right, in the right one, we attacked it with right one oxygen attacked hydronium. We formed water. Water is neutral. Water is a neutral molecule. It really doesn't like it. It really has no reason to attack something, and it usually is chill, right? However, when you have a charge on carbon, water is gonna like it. I mean, water is gonna attack it. Okay, carbon is so reactive right now. It's so unstable. It's so reactive that water is just going to end up attacking it. So now what you're going to end up forming is we're going to have a neutral intermediate. So we're going to have OH right here. We're going to have OH right. No, we're actually going to have a we're going to have a damn, I don't know what it's called. It's something like when oxygen has a plus charge. I think it's called an oxonium ion. So obviously we're going to need to deprotonate it with, what do we have in the flask? We have water. So water's going to come in and just do acid base and get rid of that charge. So water's going to come and get rid of that charge and make it neutral. So right now we don't have the neutral intermediate. Right now we're going to form the neutral intermediate. And our goal is, remember, whenever you do mechanism, remember your goal. Your goal is to make a carboxylic acid. And our carboxylic acid, do you see any ends? I don't see any ends. So obviously he's going to need to leave. He needs to leave somehow. So let's say he leaves just like that, right? First off, if he leaves just like that, he's gonna get a negative charge. We're gonna put a lone pair on that, and that's not good, right? He can't just do that because we're in acidic conditions. We can't have negative charges, so we're gonna have to protonate him first, and then he's gonna be able to leave without be. He's gonna be able to leave like neutral. So, bet. We formed like hydronium here. Either way, you don't even need to think about what we're forming. It's just like, obviously H2SO4 and water is hydronium, right? And you're gonna use something that's in like you're gonna use something that's gonna, like, let's say we used water, right? Let's say the N is attacking water. Let's say this was water and it attacks it, right? Which wouldn't happen, but let's say it does, right? This is gonna put a negative charge on water. You're gonna form hydroxide, which we can't form. So whatever reason you pick, like, not even that, like, there's so many reasons to do why it attacks hydronium. You just have to understand why you're doing it. Just avoid negative charges. So this is gonna go onto oxygen. So now we're gonna form something. Now we're gonna form a plus charge on nitrogen, which is gonna allow it to leave. It's gonna allow it to leave without any charge. So this has too many bonds, right? Nitrogen wants 3 bonds. Now he has 4, so he can leave. Just he can leave and without any charge getting on him. So now our molecule is gonna look like our is gonna. We're almost there, right? So if he leaves, excuse me, if he leaves, a plus charge is gonna happen. Is gonna get a carbocation on the oxygen on the carbon, right? So let me just write it a little bit more clear. Let me put it right here. If once that nitrogen leaves, always remember, once something leaves, carbon now has 3 bonds. He wants 4. So, but even all that, like, it's really not that complicated. Look at our answer right here. We're forming a carboxylic acid. We form a delocalized charge. So right here, we just push electrons towards the positive charge. So electron goes, the bond goes there, and now we're gonna form between it. We're gonna form a major and minor resonance structure. And so now, um, you pick between the major and minor. This is the, like, this is the this is the major, right here, this is the major, and usually you do acid base on the minor. However, this basically looks like our carboxylic acid, but if you got rid of the H. So this is why we do acid base on the major, because this literally looks like our answer. So whatever it looks like your answer, do acid base on that. So what's in the flask, and we need it either way. What's in the flask, and what are you need to regenerate the acid catalyst, which is hydronium. So water is gonna come and take and deprotonate it. Oh, this is the difference between this. Yeah, this is okay. Okay, water doesn't. Okay, so obviously, like in a lot of examples that we learned, water is the last step, right? That does it. However, we end up nitrogen. Remember how we formed the NH3 right here? NH3 is the one that comes in the end and does it. We're gonna form NH4 ammonium. So if you remember, this is how you're gonna remember it. Okay, it's like what you want, what you expect to attack in the end is water. Just remember what you don't expect. I don't know. Honestly, I really don't know the reason why the ammonia is the one that does the attack on it. I don't even know why it does it. Maybe because it's there. Or maybe because we're in acidic conditions, we're going to want to kick that H. Or I really don't know. I'll just ask the professor, honestly. I really don't know. So we're going to form NH4. So that's how you do it. Acidic condition is a lot more steps. The basic condition is it's a joke, bro. It's so simple. So, um, in basic conditions, remember you can't form a positive charge. So, let's say, in basic conditions, these are the reagents NaOH. So hydroxide. Hydroxide is gonna come and do nucleophilic addition. So the first time we did acid base, this one's gonna do nucleophilic addition. We're gonna put a negative charge on oxygen, and we're gonna form a tetrahedral intermediate right here. And so now we're gonna have OH right here, right? And we're gonna have our ammonium. So basically, we have a good leaving group. I mean, we kick out nitrogen, like it's all right, but we could just kick it out and we'll get our answer basically. So he's just gonna leave. He's a good leaving group, like CNO. Like he's he's the like okay. In most circumstances, OH was a better leaving group compared to N. I'm pretty sure CNO, right? It's more electronegative. That's probably the reason why. But the thing is, if we kick out OH, we're just gonna go back to our original structure. So in like obviously it's why in an equilibrium, it's gonna keep going back and forth, but eventually NH, the amide is gonna leave. So this is why we're gonna get our product. It's gonna look like our answer, the carboxylic acid. However, this is not the final answer because the thing is we're in basic conditions. NH3 is gonna like we have this like NH has a negative charge, right? So since we're in basic conditions, it's going to deprotonate. It's going to deprotonate this, and we're going to form something called an. I think it's called a like Let me just check my notes. I'm pretty sure it's called like an acetate or something. It's called I'm sorry, give me a second. Um, a carboxylate. So we're forming a carboxylate. So right here, we're just gonna just draw it like normally without like with a negative charge because we are in basic environment, so it's very like normal for that to happen. And so you'll have NH3 right here. And then the final step, you have to physically add acid. So acidification, you'll get your answer, right? By physically adding it, we're gonna, or I don't know if it's physically adding it, honestly. It's just you're gonna get your answer, right? You add hydronium and then you'll get your carboxylic acid. So yeah, this is how you form an amide, basic and acidic conditions.